Hello, YouTube, and
Hello, YouTube.
we're on Life After Calculus Day 4. I thought what we'd do today is take a look at the AP Calculus exam and use Sage to solve it. Ooh.
No.
Yes.
That's a bad idea.
Then no, good idea.
Why?
Okay. Okay. All right. So, let's see. Now, remember, Part 2A is all calculator active anyway, so Sage is perfect for this. But we could probably use Sage throughout the entire exam. So, 2016 AB BC1 says water is pumped into a tank at a rate modeled by W of T, liters per hour. For T equals 0 to 8 inclusive, T is in hours. Water is removed from the tank at a rate modeled by R of T, liters per hour, where R is differentiable and decreasing from 0 to 8 inclusive as well. Selected values of R of T are shown in the table above. At time T equals 0, we have 50,000 liters of water in the tank. How would you estimate R prime of 2? Let's make this a little bigger. Can you see it? All right, so 1A. How do you estimate R prime of 2? What do you say? Any ideas, guys, today? Okay, but who are you going to subtract for delta y or in this? Well, who's delta y really? It's not really delta y, it's delta r over delta t. Okay, so what values are you going to use to get close to r prime of 2? 3 and 1. Okay, let's do that. So get into your Sage cell. Wait, let me move this over here so it's close. Boom. Okay, so first thing you're going to do is put your name in here. What happened to my cell? I can't. Let's reload it. Okay. There it is. Okay. All right, so first put a hashtag, your name, the date, so we can print this out to see who's who. What's the date? The 25th? And the topic is, well, let's see, 2016 AB1 BC1. This question was on both exams. Okay? All right, so here's part 1A. What would you show? Well, here's the data. What are you going to calculate? Go ahead. Let's start you off. 950 over 2 or 3 minus 1, right? Okay, so let's write that out. Where's my Sage cell? All right, so show numerator, a numerator divided by a denominator, right? Okay, it's 950 minus 1190 over 3 minus 1. It's sort of silly, but there you go. And let's see what we get. Negative 120. Now, what are the units, though? Because look at the question. It says, show your work and indicate units of measure. So delta R is in what units? And delta T is in what units? Delta R is in liters per hour, and delta T is in hours. So we get liters per hour per hour. It's sort of like an acceleration is the rate of change of the velocity, meters per second compared to meters per second. So now it's liters per hour compared to liters per hour, right? Okay, so I don't know, where would we put that? Let's say, how about here? Units are liters per hour per hour. Is that how you wrote it? You know, you took this exam a couple weeks ago, right? How did you write it? You could do that. That's shorthand, but you don't say it that way, because if you say hours squared, that intimates an area. Do you measure area in hours squared? No. Nobody says that. All right, so shorthand, you could write liters per hour squared, like you could write meters per second squared, but you don't say that. Meters per second, right? This makes sense? We're okay? Yeah. All right, so we got negative 120 liters per hour per hour. All right, next part of the question. Everyone got that? Everyone stuck? Catching up? We're looking on with your neighbor, if you were out. Everyone got negative 120, right? Okay. Part B. Use a left 3-month sum with 4 subintervals indicated by the table to measure the amount of water removed from the tank during 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. All right, so if you're doing a left 3-month sum, where's your first height? At 0. So F of 0, R of 0 is the first height. What's your first width? What's your first delta T, let's say? Can you visualize this graph? 0, 1340. 1, 1190. 3, 950. 6, 740. 8, 700. It's decreasing, yes? So the first delta x is, or delta t, the width, is 1, right? So the first height is 1300, the first width is 1. The next height, 1190, the next width is 2. The next height, 950 with a width of 3. And next height, 740 with a width of 2. Because it's a left rectangle, we don't use the 700, right? All right. So let's write that up. Okay, so we got, we're missing him, we're missing her, we're missing him, missing her. We got her, we got missing that. Okay. All right, so let's just write that up. This is just arithmetic at this point, right? It's not the calculus that need to be easy. Need to be made easy. It already is. It's the arithmetic that's going to mess you up. Let's see. Let's do it. So part 1B says, says show. All right, I got all the numbers here. The first delta t was 1 times. The first height was r of 1 plus. The next delta t was 2 times. The first height, f of 2 was 1190, and so forth. Plus 3 times 950 plus 2 times, the last one was the delta t of 2, right? Times 740, and we didn't use the 700, and now you get 8,050. I know it was a couple weeks ago, but this sound familiar, like what you did, at least the steps you did? Okay? All right. I don't usually go over the AP. This is new for me, so I figured I'd do this to be different. What are the units now, though? Take a look at the question. The heights are in liters per hour, and the bases are in hours. So, liters, right? Because liters per hour times hours would leave liters. So I think they want units here too. So let's say units are liters. Okay. So 8,050 liters. Realize this is humans talking to humans. This is humans talking to Sage, and this is Sage talking to humans, right? We always have these 3 components going on in Sage. And is this an over or underestimate? It's an overestimate because it's decreasing, right? So all your left rectangles would be too big if you drew it. Okay. All you had to say was it's the function's decreasing, left sum will overestimate. That's a known fact. It did, didn't it? Yeah, I have it right here. Right here it says, is it an over or underestimate, right? And you said over because r prime is decreasing, right? The thing we're integrating is r prime. So we get r from r prime. Okay, C. Use your answer in part B to find an estimate for the total amount of water in the tank to the nearest liter after 8 hours. What does that mean? Well, we started with 50,000 liters apparently, right? And we just lost how many? Whoopsie. We lost how many? 8,050. But we're also gaining what? This is being pumped in, right? It's a rate of change that's changing. So how do you figure out how much water is being pumped in if this is in liters per hour, by the way? The integral from, 0 to 8. Isn't it 0? Did you say 1 to 8? All right, so from 0 to 8, we're going to find that numerical integral, or definite integral, add on the 50,000 we started, or add that to the 50,000 we started, and subtract the 8,050 we had. All right, so here we go. Where is my say-so? So part C, show the 50,000 minus the 8,050 we just got, right? Plus, plus what exactly? What should I add? The integral of this thing with respect to t from 0 to 8, right? Okay, do you remember the integrate command? Integrate. Yeah, not integrast. What was that? Okay. Okay, what goes here? The function, right? Okay, that was 2,000 times, remember you have to say times in the meantime, it's not implicit, e to the, you can do star here, but they allow you to use carets, that's new, quantity negative t squared over 20. Okay, now that's the function we're integrating. With respect to, you got to say what you're integrating with respect to. In other words, it would be a dt from a is 0 to b is 8. All right, let's see what we get. Oh, what did I do? What did I do? Oh, did it say? Does oh, okay. Other versions of Sage actually allow you to use T and X. Okay, we're gonna have to var T here. How about I var T right here? Whoa, put the parentheses in the wrong place. Let's put it over here. Why? Hang on, one disaster at a time. All right, what happened? All right, now it uses what's called the IRF function. What the heck? Okay, so that's the exact answer, but they don't want an exact answer here. They want this to the nearest leader, didn't they? Right? Look at the question. Give me the answer to the nearest leader. So you want this numerical, right? Or if you're using a T84, you would automatically get that. That's what most people are doing. So how do you make this a numerical answer? By the way, do you know who IRF is? IRF is the normal curve from AP statistics. That has a name. It's called IRF, the error function. Yeah. Yeah. Okay, there you go. That's everything. You missing stuff? Well, how do I make this a numerical result instead of an exact result? Remember, there's a command to make it a digits. It's the integrate that's making it exact, right? Well, this is also exact. This is also, even though we're rounding off. Dot, what? Eighths? Int? No. Didn't we use this the first day? Remember when we did n, right? Remember when we wanted like a million digits of pi, right? We'd say dot n, so many digits, right? Well, dot n will also take an exact value and turn it into numerical value. So we call that nifying. That's not an English term, sorry. So what do we get if we nify it? All right, now they want this to the nearest leader. What would you write? Okay, so 49,786 liters. All right, so let's write down the final answer right here.
Wait, when you identify it, but we didn't identify
I'm nifying this part because this is what gave you the exact answer in terms of IRF.
I know, but we didn't choose the right digits, so how do you...
Right, it defaults to this many digits. You can change it if you want. But I don't really need those digits because they want this rounded off the nearest whole number, right? The nearest whole number of liters. So let's write down the answer here. 49,786 liters. All right, how about that? All right, any questions how we did A, B, or C? BC1. Lilters. Yeah, that's a new unit, by the way. They just came up with it. No, wrong. Now, if you want more digits, you could specify, you know. You could go crazy and say, okay, digits equals 1,000 digits. Let's see what it is. There it is. All right, so if you want 1,000 digits, start writing that on your paper. Go ahead. Zow. Right? Right, just copy and paste. Well, you can't copy and paste our show result, but you can copy and paste a print result. So if you make this a print, you could do that. But I don't need all that stuff. So get rid of the digits. It's 1,000. That's crazy. So it defaults to a certain number of digits. All right, whatever.
Do you want us to print this right
No,
now?
leave it like this. So leave it like that so it doesn't waste paper. Oh, by the way, I realized the other day that when you do a million digits and it's all in one line, it used to make multiple lines on screen. It used to waste paper. It doesn't waste paper. It just prints out whatever on the screen. So. All right. So anyway, that's A, B, and C. Any questions so far? Who's stuck? Anybody stuck?
You actually printed that out.
Huh?
You actually printed it out.
Print what out?
The blank digits.
Oh yeah, didn't you get it on Edmodo? I put it on Edmodo.
I want to check.
Look it up. It's on Edmodo. The million digits of pi? Let's see, do I still have it here? What happened? Wait. Nothing's wrong with what? Oh, the cord? No, we don't talk about this now. No, we don't talk. All right, wait. Didn't I?
It's perfectly fine.
It's perfectly fine. Yeah, that's what we're gonna say. All right. Didn't I? Here it is. Guys, I put this on Edmodo. Here's the million digits of pi right here. Uh-oh. I just used up all my RAM. Uh-oh.
Down some more.
Now I just broke everything. I hope I didn't break my screencast.
Down
Ah.
some more RAM.
Did I just break my screencast? I just used up all my RAM printing out 1,000,000 digits of pi. I gotta download more RAM. Oh God. Can I get out of this? Oh, please go away. I'm gonna have to get rid of this. Is there an exit? I can't exit. Come on, come on, come on. Oh, there it is. Good. Okay, here's the 1,000,000 digits of pi. Let's see, 463 pages. This is only page 1. All right, you know what? I'm gonna get rid of this before it kills my RAM for real.
Fast and free.
Okay. Anyway, that's on Edmodo. So, part D. Part D. For t equals 0 to 8 inclusive hours, is there time t when the rate at which the water is pumped into the tank is the same as the rate at which the water is being removed from the tank? Explain why or why not. And what did you say?
Yes,
I don't know.
But why?
because that rate is the WT is increasing, RT is decreasing.
No, they're both decreasing, aren't they?
What's the question?
D, 1D. Intermediate value theorem, perfect. Right. That's it, done. Just write intermediate value theorem, walk away. That's it, your work here is done. Well, now remember what the intermediate value theorem says. What does it say? If you have a continuous function, now these are differentiable, right? Didn't they say that W of t and R of t are both differentiable? Okay, but remember that differentiability implies continuity. So intermediate value theorem is a theorem about continuity, right? So we got continuity. If your function is continuous, and say you have your function has a value, I'm going to make up something, 1,000 somewhere, it's equal to 1,000, right? And somewhere else it's equal to like negative 500. You can get any value in between you feel like, namely 0, right? So what they want to know is when is W of t equal to R of t? Is it ever equal to, are they ever equal to each other in this interval from 0 to 8 hours? Rolle's theorem is related, but you really need to invoke the intermediate value theorem. Rolle's theorem, you need the intermediate value theorem to prove Rolle's theorem, but Rolle's theorem is not talking about the values of the function, it's talking about the values of the tangent, the slopes of the tangent lines. Right? Rolle's theorem says if you have f of something is 0 and f of something else is 0, the secant line slope is 0, somewhere along the line the tangent line slope has to be 0 also. Right? And the mean value theorem says that it doesn't have to be a slope of 0, but a secant line can have the same slope. Right, so we're not talking about slopes. We're not talking about the rate of change or the rate of change. These are rate of changes already. All right, so when is W of t equal to R of t? When W minus R is 0, right?
Yeah.
So think about it. Is there a maximum value you can name for W minus R? No? See, W is decreasing and R is decreasing on this entire domain from 0 to 8 hours, right?
Yeah.
Okay, so if there's a W max and an R max, W max minus R max is the maximum value of W minus R. What I want to know is when W minus R is 0, if ever. When is W equal to R? When W minus R is 0. So if I can get a max value of W minus R is positive, and a min value of W minus R is negative, then W minus R must be 0 someplace. So what is the maximum value of W? Let's find out. Let's find out. Here we go. So number 1D. What is, let's see, W max? How about that? W max is, well, here's W, this thing. Where is it going to be the max? At 0 or 8 or somewhere else? Where's the max of this function? At t equals 0, at t equals 8, or somewhere else?
Oh, 0.
At 0, because it's decreasing, remember, right? This is not W, this is R. We don't know values of W, do we? So let's calculate it. Okay. So let's just say, okay, so it's, okay, how about this? W of t is, whatever they gave us. What was it now? 2,000. You know, I have it right here. I'm just going to copy it. This thing. Right? Just copy this, highlight with your mouse, Control C, put it here, Control V. And then I'm going to say that W max is W of 0. And let's show it. So what is W max? It is 2,000. Okay, did you need the calculator for that? Or the computer for that? If you plug in 0 for t, you got an exponent of 0. E to the 0 is 1 times 2,000, 2,000, right?
Can you show that again?
Okay, so boom. Okay. Now I know W max is 2,000. What's R max? R max is sitting right there. What is it? 1340. All right. So how about what we're really interested in is W max minus R max, which is W of 0 minus the 1340. That's what I'm really interested in. Let's see what that is. W max.
Minus?
I'm making this really wacko variable name here, okay? By the way, it's in what's called camel case. What did I just do? Camel case? Nah. All right, so 660 is W minus R max. What's W minus R min going to be? What's W minus R min going to be?
I'm still working on it.
You can make your variable names crazy, right? That's just one variable name. It's what's called camel case, like a hump in a camel, so you can see each word that's stuck together a little easier.
660.
And you got 660, right? Okay, so let's write that down. How about R min, W min minus R min is going to be what then? How are you going to calculate W min? W at 8, exactly. Minus the R min from the table. What's the R min on the table? 700, okay. 700. And let's show that. Show that oh, well, do we really want that? Well, how do I fix that? That NFI. I think I could put it here because this is what's giving you that. Or I could put it here if you want. Dot NFI. NFI is not a word. So it's negative 618. Look at it. All right, so what does the intermediate value theorem say? If W minus R is 660 at t equals 0, and W minus R is negative 618 at t equals 8, what does the intermediate value theorem tell you?
Wait, can you go back up? I don't know why.
Right there.
Mr. G, I got a problem.
Okay. Coming around to fix problems.
I
Fixing problems.
I don't know. This is the same thing, but it's like this is not. Oh, never mind.
Oh, W right there. All right, so you've got W minus R max is 660, and W minus R min is negative 618. What does the intermediate value theorem tell you? You can get any value in between, namely 0. So if W minus R is 0 somewhere, W must equal R somewhere between t equals 0 and t equals 8, right? Okay, so based on that work, as long as you say something like yes, you got to say the answer, right? You got to answer the question. That's the work. The answer is yes by the IVT. That should do it. You might want to write a full sentence in English, but there you go. Okay? All right. Any questions how we did BC1, AB1, BC1, 2016?
I have one question.
Yeah. Can you print now? Yes, you shall print now.
Wait, where did you answer it?
The answer, I put it in the comment. Yes, the answer is yes. Is W ever equal to R on the interval from t equals 0 to 8? The answer is yes. Why? Because of the IVT. And where's the work that supports the IVT applies? Here it is.
Don't you have to relearn this classic comment?
Well, some people actually take their credit and run.
Yeah,
After they take the AP, they get some credits and run.
Well,
Then go to Calc 3. You're in BC, which is Calc 2 in college. Yeah. All right. So you ready to print? Everyone has their name at the top? And everyone has all these outputs here? Just these 5 outputs. That's it. All right. So Control P, enter. I'm gonna
I
print.
know why, because sometimes when you just go back and change stuff, I like to see what I did, what I based it off.
As long as you got the 5, I got plus is okay. Plus more stuff is okay. All right, my printer network died. Come on, computer.
Oh yeah, me either.
See how it's graying out? That's my network died. Come on, network. I printed the wrong printer. I was gonna print the other printer, but I don't have to. Ugh. Come on, computer. All right, can I just exit this? Come on, go away. Oh, make it stop.
He's literally ripping apart his textbook cover. He destroys everything.
That's okay. I don't care what he does with his textbook cover. I got his textbook already. I'm safe. Okay. All right. Well, YouTube, I think we're gonna say goodbye. All right. Have a nice day, YouTube. Bye bye.